In the last video, I showed you how to go from raw data to these processed data and then how to graph that. If you haven't watched that video, it's probably worth watching that one first. So this video is about the next step, how you go from representing your data to actually analyzing those data and looking at the effects of your, evaluating the effects of your methods on the quality of the data. So first thing is to take these and put them into your Word file. That can be done by copying and pasting, and what I've done here is got the report writing template. You would have filled out these sections and then I've just pasted this into the results. So here's my results table. Things to notice. First of all, that the table has a title, the effect of watering on the mass of fruit produced, that each column heading has its title, the water in litres per day or the mass of fruit produced in kilograms. So they have the units on them there and there. I've got my raw data and processed data on this because it's got not too much raw data, but if you had a lot of raw data, you might want to move that to an appendix and just show the processed data. A couple of things to notice about this table that aren't quite right. One is this one here, because this average takes into account those 3 data points, I've ended up with a recurring decimal, 98 2/3. There's really no point in going to all these decimal places. We're just measuring fruit to the nearest kilo. All of the data is to the nearest kilo. So for presenting those data, I'm just going to rewrite that as 99 kilograms. That's really all we need in terms of the amount of data that's there. The other thing is, when calculating this of 133 average, I did not include that 42 because it was an outlier. You can check that in the other video. So I just need to make sure that I've made my reader aware of that. So I'm actually going to include this statement at the bottom saying that this data point was determined to be an outlier and was excluded from the calculated average and also from the graph. So if you are going to exclude a data point as an outlier, you need to refer to that and make it very clear to the reader, but still show those data in your appendix or in your raw data. So when we plot this, again from the last video, we're taking the water in litres per day as our X values and the average mass of fruit produced as our Y values and plotting those directly. So I should be able to find any point on here. 20 litres goes with about 155. I can see that 20 litres goes with 156 there. So each of those data points is represented by my table. Again, the graph has a title and the axes are labelled with the units. So that's one thing about transposing it from Excel to Word, but then the next part is actually what you need to do in your discussion. So let's have a look at some of those things from the planning sheet around the discussion and how we might fill those out. So the discussion section has 2 parts really. One is to analyze and interpret your findings, and then the second is to evaluate the methods and the quality of your data. So to help you with that, I've got these tables in your planning sheet, and remember the tables are just to fill out some ideas that we can discuss and refer to, but then you're going to have to convert these to prose, full sentences and full paragraphs. So your analysis of your discussion in the end will look like sentences and paragraphs, but to help plan it, here's some things to think about. So what are the trends of the data? So let's have a look at what I've written in here. So the mass of fruit increased with the level of watering and no further increase was found after 20 litres per day. So all we're doing there is just looking at this, it's increasing, but it doesn't increase forever, it levels off at 20. So that's really the first part of interpreting your findings, is to just tell me about the trends in the graph. You do need to explain that. So was it expected and why? So that was expected to increase, and the reason why is because that more water would be taken up by the roots, meaning that more water is available to increase both the number and size of fruit. And so that's taking it the next level to explain. So the first thing is just to describe what does the graph look like and explain using biological terms why you think it would have gone that way. Next bit's looking at the quality of the data. So I've said that's pretty reasonable quality. We had 3 replicates, as in 3 trees that we were taking the mass and then averaging it, and the averages were on or close to the trend line. So you can see that some of these don't quite meet that trend line, but generally they're pretty close. This is also an opportunity to talk about the outlier. Obviously that tree 10 litres per day was excluded from the average. You'd want to talk about that in your discussion. And the precision. Now the precision, when you're talking about that, actually refer to your data. So they're generally good other than that outlier. Most values were close within the treatment groups. This particular treatment group had a high range of 23 kilograms. Now what do I mean by that? So precision, you can actually look at this directly. Precision is how close those replicates are to each other. If the replicates are all very close within a couple of kilos, 1 or 2 kilos, that would be very precise data. What we can see here is they're generally within 10 to 13 kilos there. So that's not bad. That's less than 10% of the value. So they're going up and down within 5 to 10%. That's not too bad, other than this one. And when I say the range is 23 for this group, you can see that the lowest is 89, the highest is 112, so there's 23 kilos difference, which taken as a percentage of 89 is actually over 25%. So that's quite a lot of variance within that. Even taken as a percentage of the average, it's about 20%. So that variation is perhaps a bit high, and so we could talk about low precision within that treatment group. And again, just a reminder, treatment groups, the 30 litres per day is called a treatment group, and all of those replicates, we expect those replicate data, if there were no sources of variation, would be identical, but we have variation in there that's causing that difference and that lack of precision. Okay, so that's about analysing the results in the data. Now, the next bit might be helping us to explain why there is variance. So, sources of variability. And so what we do is in this first column, we're just going to identify some sources of variability. Why is it that with 30 litres per day, not every tree is yielding the same 157? This one's a bit higher, these two are a bit lower. Why is there that variability? Well, one of the sources of variability might be we've got just variation between trees. They're different sizes, different ages, different number of branches. Another one might be even though we're watering, adding the same amount of water, because there's soil differences, it might run off one soil more and stick into another. There might be some moisture already in the soil. Soil moisture might be different. There might be change due to loss of fruit, as in birds or animals taking away some of that fruit from the different trees. Or when we're weighing our fruit at collection time, at harvest time, there might be some other things in those baskets that are adding to the weight. So we can think of a whole lot of different sources of variability. We need to categorize those as random and systematic. So random variables that we have here might either increase or decrease depending on that particular tree, that particular data sample. Might be sometimes higher, sometimes lower, depending on factors that we call random. So the variation between trees is random. Some are going to have more branches and more fruit. Some are going to have fewer branches and fewer fruit. That's a random factor. Systematic is not going to have a random up or down effect. It will affect all of the groups about the same. So if all of the trees are losing fruit, then our mass of fruit produced by the trees is going to be an underestimate of the true value of fruit that's being produced. Same with the contamination of crops. If there's twigs in every basket, because we're doing it the same for all the different trees, that's going to increase our mass artificially. And so next thing is to talk about the effect on the data. So for instance, variation between the trees is going to decrease our precision. Soil moisture, decrease the precision slightly, because most of the moisture should be coming from that watering, and so that's going to have less of an effect maybe than the different trees would, for example. As I said, the loss of fruit would cause an underestimate, and the contamination of the crop would cause an overestimate, but only slight. I mean, a few twigs and leaves aren't going to make kilos of difference. And the last thing to add into your table is a discussion of how you might minimize that effect. So for instance, by selecting trees of the similar age and size, you could reduce that variation between the trees. Again, this sources of variability needs to be translated or transposed into your discussion as actual prose sentences. So, for example, you might be using some of these sentences here. Comparison of replicate data showed a moderate or low level of precision related to random errors. Sources of random errors include variation between trees. This would have caused random error and decreased precision. This could be reduced by selecting trees of similar age and size. There was also a random error of the variation in soil moisture, which would have decreased precision slightly. This could be minimized by selecting geographically close trees. And so here's some sentence starters to help you converting these ideas that we've recorded in the table into sentences for your discussion. So once you've talked about the trends in the data and explained them, and looked at the quality of your data and sources of variability, you're ready for your conclusions. So here, what we want to do is summarize the key findings, say whether the hypothesis was supported or not. So our data support the hypothesis that increase in the level of watering will increase the mass of fruit produced. Generalize some findings. So this was a specific example of looking at massive fruit in peach trees. I think it would probably be reasonable to expand this out to other stone fruits. So you would expect similar findings in nectarines and apricots. You could probably even extend it out to apples, oranges maybe. But at a certain point, that generalization has to stop. I don't know whether it would apply to bananas or like fruit crops like walnuts or something like that, that are a different type of crop altogether. So you might want to put some limitations on that. So although in general we might say that increasing the level of watering can increase the crop for a fruit that grows on a tree, this might be limited to other types of crops, and those would need to be investigated in their own way. But we can use this understanding too, and so you can talk about looking at the level of watering required for different crops and what they might need. And again, you might say that we maxed out at the 20 litres per day with peaches. Other types of fruit and other varieties might have different watering regimes that give them the optimum size of fruit. So there's some of the stuff about how to do your IAE 3 and 4 around some of those discussions and conclusions.